Okay, today we can start with multiplying fractions. Uh, you have done this in previous grades also, so I'll just revise that knowledge. So let's take this example: 1 over 2 times 1 over 3. What happens is we multiply the values that are in the numerator and put it in the answer's numerator. So 1 times 1 is 1, and then we multiply the numbers in the denominator and put it in the denominator. So 2 times 3 is 6. That's how we multiply fractions. Okay. If we do this example, what are they asking? Ella is eats 1/2 of 2/3 of a bar. 1/2 of the 1/2 of means multiplication. 1/2 of 2/3 of a bar. 2/3 means 2 over 3. For bar, how many squares does she eat? And we can multiply this similarly. These two becomes 2 and these two multiplied becomes 6. So now you can see there are common factors. 3 times 2, so these two cancels out. Now it is 1 over 3. So they ask about how many squares. Okay, so we have to look at the chocolate bar. So she has 3 squares, 6 squares. Okay, so 1/3 of 6 squares means 2. So she eats 2 squares. So that's the answer. Let's look at the examples. So in this example, they have given us a mixed number and a fraction. So first we have to do is we have to convert this into a fraction. So what we do is we multiply these two. 1 times 3 and this one all over 3 times 4 over 5. So this gives us 1 times 3 is 3 plus 2 5. 5 over 3 times 4 over 5. These two cancels out, so we are left with 4 over 3. This can be written as, so we can turn this into a mixed number. How can we do? How many 3's are there in 4? 1. So we are left with 1. 1 over 3, 1 and 1 over 3. So that's the answer. So multiplication is really easy. So there's nothing much to discuss. So if we get something like this, 2 over 5, 3 over 7, 5 over 6. So before multiplying, you can cancel the common factors. That's easy. So these two cancels out. 2 times 3 is 6. So these 3 cancels out. So we are left with 1 over 7. Like that. It's really easy. So let's check this 10th question. Morgan was doing her music practice for 1/4 of an hour. For 2/3 of that time, she was practicing her scales. Okay, so 1/4 of an hour. Quarter means 1 over 4 of 1 hour. For 2/3 of that time, she was practicing her scales. For what fraction of an hour did she practice her scale? So first she was practicing for 1/4, so 1/4. On that 2/3 of that time she was practicing her step. So what fraction of an hour did she practice her scales is this. These two cancels out. Now we have to multiply. We put the numerator values in the numerator. 1 times 1 is 1. 2 times 3 is 6. So that's the answer. And then if we come into the algebraic type of question, this one we can do. B over a squared times b over a times a cube over b squared. So first we can cancel the common factors. 2 b's are there. These two cancels out. Then all of these cancels out. So elected 1 over 1, that means 1. So that's simple. Like that we can do that kind of exercises also. So I will do this fourth one also. That's 8 1 over 4 times 4 4 over 11. So first thing we have to do is we have to convert these into fractions. These are mixed numbers. We have to convert it into fractions. So what we do is we multiply this to 8 times 4, add this plus 1. So first thing we have to multiply these two and add this over 4. The denominator doesn't change. And multiply these two multiplied 4 times 11 plus 4. Denominator doesn't change, 11. So 8 times 4 is 32 plus 1 is 33 over 4 times 44 plus 4 is 48 over 11. So we can cancel the common factors 3 and 11. 1. If we take 2, we get 2, 4, 1, 12. Okay, then we can get the answer by multiplying the numerator values. 3 times 12 is 36 over 1. So this is simply 36.
So now we are coming to dividing fractions. So you have done this in previous grades also. If you remember, I'm just going to revise the memory. So let's move forward. So when we do a fraction dividing problem, what we do is there are simple steps to do that. Okay, let's take this example. Okay, so first 1 over 2 divided by 1 over 3 over 1. Okay, first step is this is division. So the first step is write this without changing anything. That's 1 over 2. Now change the division sign into multiplication. So I change it to multiplication and get the reciprocal of the second fraction. So that's 1 over 3. Now this has been converted into a simple multiplication. Now we know how to multiply. Multiply the numerators. 1 times 1 is 1. multiply the denominators. So 2 times 3 is 6. So this is the answer. So do you remember about the reciprocal? So if the fraction is 2 over 3, the reciprocal is what we do is we turn the fraction upside down, 3 over 2. Okay. Reciprocal, I think you can remember. So let's go to another problem. Okay, this one. So according to the question, Ella has 2 bars of chocolate. 2 bars of chocolate. Both bars are divided into thirds. How many blocks of chocolate are there? 1/3 of a bar consists of 2 squares. 1/3 of a bar consists of 2 squares. Okay. And there are 6 blocks of 1/3 of a bar. There are 6 blocks of 1/3 of a bar. There are 6 blocks of 1/3 of a bar. Ella has 2 bars of chocolate. Both bars are divided into thirds. Ella has 2 bars of chocolate. Both bars are divided into thirds. How many blocks of chocolate are there? Okay, 2 bars of chocolate. 2 bars of chocolate are there. 2 bars of chocolate are there. And Ella is dividing it into 1/3. Okay, so that's the question. So what we do? So we write this one without changing. We wrote that one. Now we change the division into multiplication and take the reciprocal of this one. 3 over 1. So now this simply becomes, if there is nothing in the denominator, we can put 1. So this simply becomes 6 over 1. So that means 6. Right? I think that's easy. Let's check this type of question. Now you have a fraction, mixed number and a whole number. So first thing, you can write this whole number as a fraction. So if there is nothing in the denominator, you can always put 1. There's no harm in that. So 1 times 1 and 1 over 5, you can write as 1 times 5 plus 1. I told you before, you first multiply these two and add this one. Okay, so the denominator doesn't change. That's 5. So we can write this as 9 over 1 divided by 5 plus 1 over 5. So that's 9 over 1 divided by 6 over 5. Now what happens is the usual steps of division. So we doesn't change this first fraction, change the sign into multiplication and take the reciprocal of this one. Reciprocal means we have to turn upside down. Okay, so I hope that's clear. And we can divide this 9 and 3 by the same number. If we divide by 3, this result 3. Divide by 3, result 2. So now we can get the final answer. 3 times 5 is 15 over 1 times 2 is 2. So this is the final answer. And also, if you need to keep this in the mixed number form, you can do that also. How many 2's are there in 50? 7 2's, no? So that's 14. We write 7 as a whole number, and we are left with 1. 1 over 2. Because 2 times 7 is 14. But there is 15, no? So another 1 is there. 7 and 1 over 2. That's the answer. So this is the point I have told you before. To divide by a fraction, turn the fraction upside down and multiply. That's the step we have done already. So let's do something like this. Eighth one. You have to convert both the numbers into fractions. Okay. 2 and 1 over 2 divided by 2 and 1 over 4. So that's, you have to convert those into fractions. So 2 times 2 is 4 plus 1, 5. 5 over 2 divided by 2 times 4 is 8. 8 plus 1, 9. 9 over 4. Okay, now the usual steps of division. Without changing, write this first fraction, change this into multiplication, turn this upside down, taking the reciprocal. 4 over 9. Now simplify. We have common fraction, common factors. If we divide this by 2, we get 1. If we divide this by 2, we get 2. So now 10 over 9. Further, we can write this as a mixed number. How many 9's are there in 10? 1 9. We are left with 1. So 1 over 9. Simple as that. And let's do this 10th one. A bottle contains 2 and 1 over 4 liters of water. How many glasses of volume? Volume of the glass is 3 over 16 liters. Can it fill? So there is a there is a bottle that contains 2 and 1 over 4 liters of milk. We have to fill glasses that have volume 3 over 16. How many these type of glasses can be filled using the this bottle? That's the thing they ask. So we have to divide this bottle into this amount of glasses. That's the thing we have to do. So the question, if we write it as a division, becomes as 2 over 1, 2 and 1 over 4 divided by a small glasses with volume 3 over 16. So first thing, we have to turn this into a mixed number. Not a mixed number, a fraction. So 2 times 4 is 8 plus 1, 9. 9 over 4 divided by 3 over 16. So now we can do the usual steps of division. First fraction, without changing, we write it. Turn this into multiplication. Turn this upside down. The second fraction. 16 over 3. Now we can cancel the common factors. 4 times 1 is 4 times 1 is 4. 4 times 4 is 16. And 3 times 3 is 9. 3 times 1 is 3. Now you can see numerators multiply 3 times 4, 12. Over 1 times 1, 1. This becomes simply as 12. So we can fill 12 glasses like that. Okay, then the 10th one. Let's do the 10th one also. Dylan's cow produces 21 and 1 over 3 liters of milk per day. The milk put into bottles with volume, this is like a large container, let's say. We want to fill bottles with the volume 2 and 1 over 3. How many bottles does Dylan need each week to bottle all the milk? Per day, this is the per day volume that cow produces. So we want to calculate for a week, then we have to multiply this by 7 and we have to divide it by the bottle's volume. That's the case. So what we do is 21 1 over 3 times 7. This whole thing we have to divide by 2 and 1 over 3. So we have to first we have to do is we have to turn these mixed numbers into fractions. So 21 times 3 is 63 plus 1 64. 64 over 3 times 7, and this divided by 2 times 3 is 6 plus 1 7 over 3. Now it is better to keep this as this. So 64 times 7 over 3. What I did was, we can put 1 here. I did the multiplication. So that's this whole bracket is containing here. And now the usual steps of division. So we turn the division into multiplication, turn this into upside down, 3 over 7. Now these two cancels out. So we are left with 64. So Dylan needs 64 bottles each week. So that's the answer. Okay. So after doing division, we are coming to adding and subtracting fractions. So in the first sentence, they are telling us this can only be done if the denominators are the same. If the denominators of two fractions are same, denominator means the bottom part. If the bottom part is same, we can simply add. These two added, 3, denominator doesn't change. So we put the same denominator. That's how we do. So when it comes to the fractions which doesn't have the same denominator, what we can do? So let's look at this example. 1 over 2 plus 1 over 3. So if we want to add, first we have to make these two similar. So to do that, we have to find the LCM, least common denominator, lowest common denominator. So after doing division, we are coming to adding and subtracting fractions. So in the first sentence, they are telling us this can only be done if the denominators are the same. Let's take an example, 1 over 6 plus 2 over 6. You can see the bottom parts, the denominators are same. So now we can simply add. We add these two first. Numerators we add 3. Then we put the denominator without changing anything. So 3 over 6 is the answer. So what happens if the denominators are not same? What can we do? So let's take this example, 1 over 2 plus 1 over 3. So before adding, we have to make this denominator similar. To do that, what we can do? We can multiply both the numerator and denominator by the same number. This can be done to both of the fractions. Then we can make these denominators same. So to find that, what is the lowest number that we can convert these two denominators, we have to get the LCM. I think you have heard this before. LCM means lowest common multiple. So now we have 2 and 3. So we have to find the lowest common multiple. So now we divide these two numbers by prime numbers. So the first prime number is 2. You know prime numbers? Prime numbers starting with 2, 3, 5, 7, like that continues. Prime numbers are the numbers that only have 1 and itself, only 1 and itself as factors. Okay, 3 also have 1 and 3 as factors. 5 also have 1 and 3 as factors. 1 and 5 factors. So if it has more than 2 factors, other than 1 and the same number, it is not a prime number. So prime numbers are like this. So we start with the lowest prime number, divide. Then we get 1. If we can't divide 3 by 2, we just put the same number again. And then try the second prime. Now we can divide. We put 1 and 1. So by multiplying these two, we get the LCM. 2 times 3 is 6. So we have to make these two denominators into 6. So what we can do is we have to multiply 2 by 3. If we multiply by 3 the denominator, we have to do the same to the numerator also. Now this one will become 6. So we can multiply 3 by 2 to make this 6. If we do that to the denominator, we have to do the same to the numerator also. Now we can write 3 times 1 is 3 over 6 plus 1 times 2 is 2 over 6. Now we can add these. So numerators added, we get 5 over denominator doesn't change, 6. So that's the answer. So let's try one of these examples also. Let's take this. 3 over 4 plus 1 over 6. Okay, so we can see that these two denominators are not same. So we have to find the LCM. So we are going to divide by prime numbers. 2. 4 divided by 2, we get 2. 6 divided by 2, we get 3. Then we can again divide by 2 because there is 2 there. Okay, until it can't be divided, we do again and again. So then we get 1, 3. Again we divide by 3. 1, 1. Until we get all the numbers into 1, we repeat the process. So LCM is then 2 times 3 times 3. So that's 6 times 3, 18. So yeah, then we can 4, 6 is divided by 2, get 2, and 3, divide again by 2, 2, sorry, I wrote it wrong. So 4 times 3 is 12, sorry. And now we have to make this into 12, so we divide by 3, both numerator and denominator. This 12 it will be multiply by 2, both numerator and denominator. So 9 over 12 plus 2 over 12. So that's 11 over 12. So that's the answer. And now, up until now, we did only addition. So subtraction also similar. Let's try this one. 3 over 4 minus 2 over 5. We can't subtract if the denominators not the same. We have to make those denominators into same number. So we check the LCM first. Divide by the smallest prime number 2, get 2, 5. If we can't divide, we put the same number again. Can't divide means if we divide 5 by 2, we get 2 and half. No? We only get whole numbers. If we can't get a whole number by dividing, we put the same number and try a different prime number. Then if we divide by 3, we won't get a whole number. So then we try by 5. 1, 1. So this is the LCM. So that's 2 times 2 times 5. That's 4 times 5 is 20. So now we have to make this 20 multiply by 5. This multiply by 4. So 15 over 20 minus 8 over 20. We can subtract these two. 15 minus 8 is 7 over 20. We don't change the denominator. Okay. So then let's try this one. It contains two mixed numbers for the. So the first thing is we have to convert those into fractions. So what we do is 3 times 3 is 9 plus 1 10 over 3 minus 1 times 4 is 4 plus 3 7 over 4. So these two we have to make same. So 3 4, check the LCM, divide by 2, 3 2 again by 2, 3 1 again by 3, 1 1. So it stops. LCM is 2 times 3, that's 12. So we have to make this 12. We divide by multiply by 4, multiply by 4, multiply by 3, divide by 3. So then 12 over 40 minus 12 over 21. So we get the answer as 19 over 12. So we can make this into a mixed number. How many 12s are there in 19? 1. So we left with 7. 7 over 12. So that's the answer. So these are the key points. To add or subtract fractions, put them over a common denominator. That's the thing we have done in using LCM. Less work is needed if the common denominator is the lowest. That's why we find the LCM. Okay. So these are many practice questions are there. You can try it yourself. And you can check with the calculator. But don't use the calculator first. Just do it yourself and check the answer with the calculator. Okay, so let's try this 13th one. Lithium Li leads one part of, oh, so no, this is lithium. This is Li. a girl does one part of her homework before dinner and a further one third after dinner. What fraction of her homework remains undone? So let's think that Lee's homework is 1. Okay. So Lee does one half of her homework. So what is remaining? 1 minus 1 over 4. That's the remaining. So that's, we all know that we can write 1 as 4 over 4. Okay, 4 over 4 means if we cancel those 4 out, it will remain 1. Then 4 over 4 minus 1 is 3 over 4. So before dinner, she did 1/4. So the remaining is 3 over 4. And further 1/3 after dinner. She did another part of the homework after dinner. So 3 over 4. She did 1/3, 1 over 3. So now let me get the LCM. 3, 4, 2, 3, 2. Divide by 2, 3, 1. Divide by 3, 1, 1. So LCM is 2 times 2 is 4, 4 times 3 is 12. So I multiply by 3 to make this 12. Do the same. Multiply by 4 to make this 12. Do the same. And 9 over 12 minus 4 over 12. Then 5 over 12. So that's the remaining part of a homework. Okay, so I think you got some idea. So order of operation. So if we get something like this, 3 plus 4 times 2, the answer depends on what we do the first. So if we do the multiplication first, we get 3 plus 8. That's 11. If we do the addition first, we get 7 times 2. Then we get 40. So two answers are different. No? So that can't happen in maths. So there is an order to what to do to determine what to do first. Okay. So that this is the order that we follows. So this can be remembered as bit maths. Or otherwise you have heard this before as board maths. Those two are similar. Okay. So the first thing we have to do is brackets. The second thing we do is indices or otherwise order. Indices or order. The second thing is indices or order. Indices means if we see some powers, we expand this first. So write this as this. And the third one is division and multiplication. First thing we are doing is brackets. Then if we see a power, we do that. Then we do division and multiplication. Finally, as fourth, we are doing the addition and subtraction. That's our order of operation. So they have given us an example here. So by looking at this, you can see there's a bracket. So our first thing is to do that. So 5 minus 2 is 3. That's 3. And second, we have to do the indices or order. Then we get the 2 to the power 2. That's 4. Okay. Then division and multiplication. So we do the division first. 3 divided by 3 is 1. Then multiplication. 1 times 4 is 4. So after that, addition and subtraction. Subtraction 7 minus 4 is 3. 3 plus 5 is 8. Okay, I think that's clear. Then let's try some example. And one thing, if we see something, like this, that means 1 plus 2 is in a bracket like that. Okay. If we see something like this, we have to know that this means something like this. Okay, you can do this activity yourself. You have to check with your calculator. So they have mentioned this action means like this. So you have to put brackets when you work out this. So this means 16 minus 4 times 3 over 6 divided by 3 times 2. So you have brackets. No? So that means you have brackets. If you see something like this, you can put brackets. So then we have to do the brackets first. That means we have to get a single number for this bracket. So inside the bracket, now the order of operation also works. Now inside the bracket, first we do is this 4 times 3. So 16 minus 12 over, and inside this one also the order of operation works. 6 divided by 3 is 2. 2 times 2 is 4. And we all still have the brackets. 4 over 4, that's 1. I think you are clear with that. Now after that, let's do this one, 7th one. So by looking at this, first you can recognize, I'll go from here to up. You have brackets. Okay. So first thing you do brackets, 2 divided by 7 minus 9 is minus 2. Okay. Then multiplied by this bracket. Inside the bracket, what you do first is multiplication. 10 minus 6. Inside the bracket also you have to do it in the order of operation. So 3 plus 2 divided by minus 2 means, so you know that same sign multiplication gives plus. Multiplication and division gives plus. Different sign multiplication and division gives you minus. Similarly, if this is a multiplication, also this works. So different signs, so we get the result as minus 1 times 10 minus 6. We have to finish this bracket. 10 minus 6 is 4. Now we are left with this. So then what we do first is this multiplication. So different signs. This becomes minus 4. 3 minus 4. So the result is minus 1. Like that. I think you got that correct. Okay, so this 10th one. This is little interesting. Insert brackets and symbols into this expression to make it correct. So this should give result as 6. Okay. What I can see is if I subtract these two, and multiply. This will give 6, but you have to put brackets. Otherwise, we do the multiplication first. Okay. Like that. I'll do the 7th one also. So this means you have to put brackets. Okay. If you see something like this, always put brackets. 6 minus 1 times 2 divided by 12 divided by 10, 2 to the power 2, 8 divided by 2 times 2. Okay, so brackets are there. We have to do the brackets first. Inside the bracket, doing the bracket means we have to get a single number for each bracket. So inside the bracket, what we do first is using the order of operation, we determine what to do first. So 1 plus, here you have to do the multiplication first because it's higher in the order of operation. So 8, and still the bracket is there. In here also you have to do the multiplication first. 6 minus 2 divided by, here you have to do the indices or the odd power first. So 12 divided by 4, still the bracket is there, and here also multiplication and division, you can do the division first. That's also same. 8 divided by 2, 4 times 2. So then we can get, then there is only one operation, so we can remove the brackets by getting a single number. So 8 plus 1 is 9. 6 minus 2 is 4. Divided by 12 divided by 4 is 3. Over 4 times 2 is 8. Now this becomes a simple division of fractions. So first thing, you have to convert this into multiplication. Take reciprocal over 3. Then cancel the common denominator, common factors. 4 times 1, 4 times 2. 3 times 1, 3 times 3. So 3 times 2 is 6 over 1, that means 6. I think that's clear. Okay, now we are going to discuss about significant figures and decimal places. Okay. The meaning of a significant figure is the first non-zero digit in the number counting from the left. Okay, let's see this example. You can see this number 27,400. So what is the first non-zero digit? That's 2, right? So that's the thing they have highlighted here. So when we come to B, what is the first non-zero digit? That's 1, right? So that's the one they have highlighted. So when we come to the C part, what is the first non-zero digit? That's the first significant number. That's 5, right? So that's the one they have highlighted. So okay. So when we use significant figures to write round numbers, what we can do? So let's say they are saying us to round these numbers correct to 2 significant digits, significant figures. So that means we only have to consider 2 significant figures, 1 and 3. So others we can omit. Okay. But when we round, you have to consider something. So we can round this 1361 into two numbers. Okay, so what should be the correct one? If this number is uh, closer to 1300, it should be the rounded number. If this number is closer to 1400, it should be the answer. So if we look at this 1361, you can see it is more closer to 1400. So that should be our answer. So 1400 is the answer correct to two significant figures because 61, no? So 1300 and 1300, 1350. In place like this, 1361 is there, and then 1004. So this is uh, closer to 1400. Then we have to select this. Then if we check this one, 1350. Always if it is in the middle between 1300 and 1400, we take the upper one, 1400. So that's why we got 1400 here. Correct, rounded correct to two significant figures. And if we check this one, you can see that this is right below the 1350, 1349. So this comes when rounded 1300. I think you got some idea. Okay, let's try these three examples also. So now they are telling us to round this correct to two significant figures. So we have to check what are the significant figures. This is one, this is the second significant figure. So we can put a dotted line between this. We can omit these numbers. Correct? Okay, then think about if this number is if these two number is greater than middle of the thing, so let's say 0.00130 and 0.00140. In the middle we have 0.00135. Okay, so when we look at 0.00131, it's in here. 0.00131 is here. So we have to take this one. That's this 0.0014. If we now we can do this without writing in a number line like this. We can check it by, if we want to get the number correct to two significant figure, we check whether the third significant figure is greater than 5 or lesser than 5. Okay, so third significant figure is 6 and it's greater than 5. So we get the upper one as answer. So if this third significant figure is greater than 5, what we do is we add 1 to the second significant figure and put. If the third significant figure is equal or greater than 5, that's the case we add 1. If it is equal to 5 also, we add 1 to the second significant figure and put 0.0014. And if the third significant figure is lesser than 5, we don't add anything, just write until the second significant figure. I think you got some idea. Then let's move on to decimal places. Okay, so decimal places mean if we write some number like this, after the decimal point, this is the first decimal place. We write it as DP, shorter for decimal place. This is the second decimal place. Okay, and not like the significant figures. If either this has something like this is the first decimal place. No matter it is 0 or not. This is the second decimal place. Okay, so when rounding, the same rules applies. Okay, now they are saying us to round this to up correct to two decimal places. So this is up to two decimal places. We check the third decimal place. If it is greater than or equal to 5, we add 1 to the second decimal place. So this is greater than 5. Then we add 1. And the answer is 7.14. Then when we come to this, our second decimal place is here. We put the dotted line and check whether this is greater than or equal to 5. So this is equal to 5. So then we add 1 to second decimal place. So 0.14 is our answer. So this here is the second decimal place. And when we check this one, it is lesser than 5. So what we have to do is we doesn't add anything to the second decimal place. So that's the answer. Okay. So here's an example, another example. This table shows 5. 5 value, you know. This is never ending decimal number. So still we are finding this is a never ending decimal number. So if we use this into degrees of various degrees of accuracy. So if we use 5 degrees of accuracy, we have to have 5 numbers, 5 significant figures. And if we use 5 decimal places, we have to have 5 digits after the decimal place. If we use 5 significant figures, we have to have 5 non-zero digits counting starting from left side. If we use 3 significant figures, this should be like this. If we use 3 significant decimal places, we have to have 3 decimal places after this decimal point, like that. If that's 1, this is the answer for significant figures. This is the answer for decimal place. I think you got a clear idea. These are the key points you have to remember. So the first significant figure is the first non-zero digit in the number counting from the left. And this is the second one. For decimal places, count after decimal point. Okay, decimal places we count starting after the decimal point. So this is the first decimal place, second decimal place, third decimal place, fourth decimal place, like that. And the final one, rounding. If the next number is greater than or equal to 5, then round up. Okay. So if we have 0.23346 correct to 2 decimal places, we have to check the third decimal place also. If it is greater than or equal to 5, we add 1 to the second decimal place. So this, when this is rounded up to 2 decimal places, this is the answer. I think you got that. Let's do some of the examples. Write correct to three significant figures. Three significant figures means starting from left, three non-zero numbers. So starting from the first non-zero number. So this is the first significant figure. Even if it is zero after the first non-zero number, it doesn't matter. Okay? So this is the second significant figure, third significant figure. So this is the point we have to omit from. So, and the third significant figure is 9. So it is greater than or equal to, it is greater than 5. So we have to put 803 double zeros like that. And this one, we have to write this correct to two significant figures. So this is the point we have to omit. So then we check third significant figure also. It is 5. It's greater than, it is equal to 5. So then we add 1. 0.560 like that. And this one correct to one decimal place. So this is the point we have to omit. This is check the second decimal place also, it's 0. Then we don't have to add anything. 3.0 like that. Okay, let's do some of these 30th question I will do. The speed of light is given as this. Write this speed correct to three significant figures. So significant figures are the digits that are non-zero starting from left. So this is the point 1, 2, 3 significant figures. And check the fourth one also. It's greater than 5, so we have to add 1. So adding 1 means 300. 0, 0. Other points we have to make 0. 0, 0, 0, ms minus 1 to the power minus 1. So 6 significant figures. So this is 3, 4, 5, 6 here. And check the third, seventh significant figure. It's lesser than 5. So this remain the same. 9792. Other three is zeros. Like that. Okay. I think these examples we done. These kind of examples we done. I'll do the 16th one also. The bore radius is a physical constant of value. This large number. Write the bore radius correct to 7 decimal places. So 7 decimal places. Here 3, 1, 2, 3, 4, 5, 6, 7 is this. So here we have to draw the omitting line 7 decimal places. So check the 8 decimal place also. It's 5. So it's greater than or equal to 5. So then we have to add 1. So that's 0 0.0000001. That's the answer for this. And 7 significant figures. This is the first significant. Second, third, fourth, fifth, sixth, seventh. Here we have to draw the middle line. Check the 8 significant figure also. It's 1. So we don't have to add anything. So our rounded number is 0 0.0000052917772. It ends here. We don't have to add anything. I think that's really clear now. And in exercise 7, you have revision questions starting from the beginning of this lesson. Do it yourself and check with the calculator. And more revision questions with yourself, and after that exam practice for this entire lesson. Okay, so do it yourself and check with the calculator, and if you have any question, put it in the comment section. And good luck with your studies, and thank you for listening, and please share and subscribe. Thank you.